Unit 4, Lesson 4, Arithmetic Series. So this would be defining the arithmetic series and then being able to calculate their sums. Remember, summation is when you have added up all of the terms. So we have different types of series. There's finite and infinite. So finite have set limits. So from this term to this term, infinite would be going on forever. I'm going through the vocabulary here. So a series is the indicated sum for the terms of a sequence. Finite has a start and a finish. Infinite, they would just keep going. So every time you get to the next term, it just keeps adding and adding to the sum. There are formulas again to find the sum of a finite arithmetic series. Remember, arithmetic series, those are the ones that have a common difference. So if you have an arithmetic series, your sum is going to be the term number you're looking for divided by 2, and then you're going to multiply that by the sum of your first and then whatever the last term is that you're looking for. So for number 1, what's the sum of the even integers from 2 to 100? So we would do just following that formula. Okay, we're looking for, that would be, now if we're just doing even integers from 2 to 100, that's 50 terms, right? Because from 1 to 100 would be 100 terms, but we just want the even, so it's cutting that in half. So they're using 50 as their term number divided by 2, and then the first and last term. And that'll give you your sum. So just be careful. Sometimes they're a little tricky with figuring out what the sum, the term number is. Okay. Using the sum of a finite arithmetic sequence. So a company pays $10,000 bonus to salespeople at the end of their first 50 weeks if they make 10 sales in the first week and then improve their sales numbers by 2 each week after that. One salesperson qualified for the bonus with the minimum possible number of sales. So how many sales did that person make? So that's a summation. They want to know over the 50 weeks how many sales did they make in total, adding them all up. So we have our first week. Our first term is 10, and that first week they made 10 sales. And then it says they improved their sales by a number of 2 each time, so that makes our common difference of 2. We have our formula for sums, but we need to know that first and the last term. So first we're going to write an explicit formula. So they've done here to figure out, we know the first term, we need to know what the 50th term is. So they've substituted 10 for the first term. The term number they're looking for is 50. We know our common difference is 2. 50 minus 1 is 49, times 2 is 98, plus 10 is 108. So we have our first term is 10, our 50th term, they made 108 sales in that last 50th week. And then now we can substitute those into our summation formula. So, and we have 50 terms for 50 weeks, dividing that by 2, and then multiplying it by the sum of the first and last term. So in total, they made 2,950 sales. Okay. The next problems get into summation notation. So they're just introducing a new symbol. So when you see this symbol, that means that they want you to find the sum. The first term number they're looking for is on the bottom, and then what they want the limit to be will be on top. So if I want to know the first to the sixth term, it would look like this. And then here is going to be the formula for the sequence. Okay, so they want to know what's the summation notation for this series. 7 plus 11 plus 15 plus, and continuing up to 203 and then 207. So what information can we get from this right away? We know that A1 is 7. Okay, and I also can find the common difference because it's arithmetic, right? So 11 minus 7 gives us a common difference of 4. And we substitute that into our explicit formula to get the formula that we're going to plug in right here. So a to the n is going to be your first term plus n minus 1 times your common difference is 4. Sometimes on your assessments they leave it just like that. Other times, you can distribute here. 4 times n is 4n, and 4 times -1 is -4. And then 7 and this -4 are like terms, so we can go ahead and simplify those. So you get 4n plus 3. Okay. Then if we want our summation notation, then we would do the sum. Okay, 4n plus 3 is our formula, and they wanted, next we need to figure out, we went from the first term to, well, the last piece that's missing is how many terms is it? So we have our last term, it's 207, but I don't know what term number that is. Is that the 10th number in the sequence? Is that the 50th? So again, we're going to take what we know and substitute it into our formulas. So we have our explicit formula. I know my last term is 207. So I can solve for n. Okay, so I know that this was my 51st term. So our summation, I want to find the sum from the first to the 51st term, and this is your formula. Okay. The next one's for finding the sum. What is the sum of the series? These you can do by going through and like this one here, substituting. So they want the sum from the first to the 7th term for n minus 1 squared. So they've put in a substituted 1 for the first term, 2, 3, 4, 5, 6, and 7. Calculated each of those, added them all up to get the sum. For this one, they have used, we know the explicit formula. So they found the first term. So they did 5 times 1 plus 3 to get the first term. And then they want the 70th term. So they did 5 times 70 plus 3 to get the 70th term. And then use the formula n over 2 of a1 plus an. Okay. You also can use your calculator to calculate sequences and series for you. So let's use this one. So if I wanted to find a sequence, you press the yellow button and then stat, and then go to ops, and number 5 is sequence. So what you do is you type in your equation, so we use x's instead of the n's, so 5x plus 3. You put in a comma, you tell the calculator what variable you're using, and then you want the first term to, let's say I want the first 5 terms. And then the calculator will tell you what the sequence is. And then if I wanted the sum, you'd press the second stat button, go to math, sum, then second stat button, ops, sequence, and then I would put in the same formula, comma, what variable I'm using, and then I'd want, let's say, the sum from the first to the 5th term, and it will tell you your summation. Okay, there's a graphing calculator help video going through that again, also attached in the lesson, and then the graphing calculator topic on the message board. So if you ever need a reminder for how to do those steps and how to use the calculator to solve those.